In this lesson, we will learn about the merge sort algorithm. Begin by downloading the merge sort algorithm document in either Microsoft Word format or PDF so that you can follow along during the lesson. The merge sort algorithm is very complex, and it will be very helpful if you can refer to this document as the lesson continues. Finally, you will also want to download the MergeSortIntroduction project to import into Eclipse. Let's begin by bringing the project into Eclipse using File, Import, Existing Projects into Workspace, browse to where you have the file stored, and then click Finish to import the project. The project has some skeleton code in it that will help us develop our program a little bit more quickly. But we will not start with this method. We will begin by creating a new class within the default package. This class will be called Combine List or Lists, and it will have a public static void main method. Click Finish to begin, and as always, we'll delete the extraneous comments. Use the one remaining comment in the main method to put your name into your code. Before we begin, let's look at the Word document to get an idea of what we will be attempting to accomplish. The merge sort algorithm is actually made up of two parts. In one part, the merge sort algorithm takes two lists and merges them together. The important part about this algorithm is that each of the lists is already sorted into ascending order. If it's a numerical list, that means, of course, that each of the lists is numbered with the lowest number first, going up to the largest. Those two lists get put together into a combined list, which then has all of the values in numerical order. In the example diagram on the first page of the merge sort algorithm document, you can see that one list has 2, 3, and 5. The other list, 1, 4, and 6. Those two lists will be combined to give us a list of the numbers with 1 through 6. The code will be right here that we'll be putting in. So, we'll begin by creating our two lists. Two integer arrays. We'll call them list 1, and we'll just give them our initial values. We'll also create a list 2, which will have our other set of values. The only requirement at this point for these two lists is that each list is in numerical order. And then finally, we're going to need an empty list that we can use to hold our combined list. And therefore, we use the new operator to create a new integer array, and the size of the array is equal to list 1's length plus list 2's length. Now, of course, we could have just said a length of 6, but writing the code this way makes it more flexible. If we wanted to test our program by changing the values in our lists, this code would continue to work. It is more robust when written this way. Okay, next we need to create a couple of index variables. So we're going to have list 1 index and set it to 0, and then also list 2 index, which will also be set to 0, and then finally a combined list index, which will be set to 0. In our next step, what we will be doing is writing the code that will go through these lists and merge the two lists together. So, what are these variables and what do they mean? Well, list 1 index is going to tell us which portion or which value within the list is the next one that needs to be processed. List 2 does the same thing for list 2. And then combined list tells us which element we're on within the combined list. Okay, let's begin writing our method. So, the first step is to write a loop that will continue as long as either of our lists has an element that has not, actually, as long as both lists have elements in them that have not yet been processed. What does that mean? Well, that means that if the index, for example, of list 1 is still less than list 1's length, then our loop should continue. But only if the list 2 index is also less than its list length. What this essentially means is that of our two lists, both of them still have elements in them remaining to be processed. When list 1 index reaches the value of 3, it means that all the elements in that list have been processed. Of course, there's no code to do that yet, but that's what we'll be writing very soon. So, now what we need to do is write our actual statement that figures out which list we want to take a value from. And what we want to do is take the value that is lower from the two lists. So, this is going to be an if statement. Well, what is our conditional? Our conditional is going to look at list 1, where we're pointing to in that list. Remember, list 1 index tells us which element we're processing from that list and compares its value to list 2 list index. And if that value is less than the value in list 2, so for example, right now when we run this program the first time, each of these values, these two list indexes, have the value 0. So it's comparing 2 and 1. And what it would say is if 2 were less than 1, of course it's not, so let's write that also. That will be our else. We now have two possibilities. Either the value stored in list 1 is lower, or the value stored in list 2 is lower. Since in our example here, the value stored in list 2 is lower, let's write that else condition first. Well, what do we want to do? What we want to do is take the value from this list, list 2, because it has the lower value, and store it in the next position in combined list. So what is the next position in combined list? Of course, its next position is the value pointed to by combined list index. So its value gets the value of list 2 at position list 2 index, because that's the element that we're on in that list. Next, what we need to do is we've just taken an element from this list. So the next time we're examining that list, we want to go to the next element, which would be 4. To go to the next element, we increment that list index. And that's all there is to it for that one. Now, obviously, 2 was not less than 1, but sometimes the value stored here will be less, and we need to process it. It's essentially exactly the same. We take the combined list index, but this time we set it equal to the value of list 1 at its index. Okay, now, we've either done this or we've done this. In either case, oops, we forgot one little thing. We need to increment list 1 index. That would not have worked. Okay, now back to our lesson. If we have added an element to combined list, then the next time that we process it, we need to go to the next element in its list. So we need to increment the combined list index. Now it's worth noting we could put this command in both the if and the else, but since one or the other of these happens, either way a value has been added to the list and we can increment it. So instead of putting it in there twice, we're simply going to include it once. Okay, Now, at this point, let's follow the code and see what would happen. Well, when list 2 index and list 1 index both have 0, it will compare 1 and 2, copying the value 1 into the combined list. Then it will take the next item from list 1, which is still 2, and compare it to 4. In this case, 2 will be less than 4, so it will take 2, and the next item on that list will be 3, and the process will continue. So, all we need to do now is, it would be nice if we could see the results of our labor here. So, let's write a little method that will let us see the results of our array. By now, this should be fairly old hat. We're going to list the contents of our array, and we're going to write a loop that iterates over all values of the array, incrementing our value for each step, and then we'll just print out the value. We'll also print the index of the value that we're outputting to make it a little bit easier to read. Okay, so what we're going to want to do is print out our list after we have combined our lists. So we'll say list combined list. Okay, now we're going to put a stop into our program right here so that we can watch as our program runs through this process step by step. Keep in mind that as you're doing this, if you look at this diagram, you should be able to follow along and see what's happening. It should be filling in combined list one step at a time from each of our 2 sublists. Okay, so let's run it in debug mode. Alright, now, if we click on combined list down here, we can see its current list of values displayed down below. Since list 1 and list 2 are relatively short, we can also open them up so we can see their values. And since we're not going to see anything in the console for a bit, we can shrink that down. Okay, so we can see that at this stage of the program, list index 1 and list index 2 are both 0, as is combined list index. So let's run our program one step at a time. So as we can see, since the value stored at list index, or list 2 index, is lower than the value at list 1 index, it's going to take that value and copy it into combined list. So we get 1 added to combined list. What's going to happen on the next iteration? If I hit resume, it will go back up here. What value will get copied into combined list next? Well, of course, it should be 2, which is the next value of list 1. Because, as you can see, list 1 index here is pointing to element 0, which has the value 2. List index 2 is pointing to index 1, which has the value 4. 2 is less than 4, so if I take one step in my program, it goes here, combines, it's going to copy list index 1's value into the combined list, and now I can see that I have 1 and 2. Let's run it, and this time we're just going to step through by hitting resume, one step at a time. We can see that we got 3, 4. What's our next value? Well, our next value in the list should be 5, but is that what happened? Let's switch back to our Java view and run the program and see what results we get. 1, 2, 3, 4, 5, and 0. Why isn't the last element filled in? Well, this is a very important step in the merge process. Remember that our loop stops as soon as one list gets to the end, runs out of values to compare. So what we have to do now is copy the remaining values from the list that still has some values in it. So this is going to be another while loop. Now, since we don't necessarily know which list has the values in it, we need to do a while loop for each list. So we're going to say while list 1 index is less than list 1 dot length, and then we're simply going to copy any remaining values in that list. So we'll say combined list index equals list 1 index. And then we need to increment both list 1 index and combined list index so it can complete the copying process. Okay, now that takes care of list 1, but what about list 2? Well, it turns out this is fairly easy. All we have to do is copy and paste our code and change our list 1s into list 2s. Everything else remains the same. So, once again, why do we have two while loops? Well, let's remember that one of these two list index variables will have reached the end of the list, which means that that while loop will not execute. Which one will it be in this case? Well, we can run it in debug mode again and we can watch this happen. What we'll do is we'll put a stop here and we'll put a stop here so we can see when one of these two while loops gets reached. So, we're going to copy. We see that 1 gets put in the list, then 2, then 3, then 4, then 5, and now our top while loop up here has completed. Notice that it has skipped list 1's while loop completely because only list 2 has a value in it remaining to be copied. 6 still has to be copied into our combined list. So let's watch that happen. There we go. It should have just been copied. And our program is done. So now let's run it in Java, in our normal Java mode, so we can see, Java out of bounds exception on combined lists line 26. Oh, I missed a 2. I didn't change that list 1 to list 2. Okay, well, that takes care of that. And there we go. Now we see that our list has been combined in order. Now, the important thing to understand about this process is that this only works if each of the sublists has already been sorted. But remember, our whole goal here is to take a list that isn't sorted and sort it. So how does this help us? Well, the merge sort algorithm is often referred to as a divide and conquer algorithm. What it does is it divides the list that we're going to be sorting into smaller lists and then proceeds to merge the smaller lists one at a time. So we'll see how that works very shortly. Before we do that, we're going to take our program here and we're now going to make this process more useful to us because so far we've taken two lists that are totally separate and merged them. But it turns out that this isn't a very convenient way to work. So in the next portion of this lesson, which will continue shortly, in the next video, we will take the same process and we'll write it as a method that operates on one big list, but operates by taking two portions of that list and merging them. Now let us continue writing our merge sort algorithm. What we need to do next is take the basic concept and apply it to working on a list where the source array gets merged without creating separate lists. What that essentially means is that we're going to take a big list that contains multiple elements and divide it into two subsections and merge those two subsections back into the same original list. So, let's look at what we need to do to accomplish that task. First, we will need to create a temporary array that has the elements of the source array that we want to be merged. So, before we could do that, we'll need to write our method header. The MergeSort header has already been written, but we're going to write another method that the MergeSort method will use. So we'll start with the public static void keywords, and we'll just call this method merge. It will take a source array, and then it will take a series of parameters. The first parameter represents the left side of our list, or the start of the left list. So we're going to call it left start. The second parameter sort of represents two different things. So we're giving it a different name. We're calling it middle index because it represents the end of the left half of the list and the start of the right half of the list. Finally, we're going to give a final variable that tells us where the right half of the list ends. Okay. Now, if we look at what our step was going to do, it's first supposed to create a temporary array that has a copy of the source array elements to be merged. So let's do that first. We're going to create an integer array, and this integer array is going to be our temp array, and it's going to be a new integer array that has the same number of elements as our source array. This is, of course, an empty array at this point, so next we need to copy our values from our source array into our temporary array. Now you might think that we're going to copy the whole source array, but remember we only need to operate from left start to right end. So instead of I being equal to 0, it's going to be equal to left start, and it's going to continue as long as it is lower than our right end. And each time it will be incremented by 1. Then we'll give our temp array of I the value of our source array of I. Okay. Now, before we continue, we're going to put in a few other protective measures to make sure that this merge method doesn't ever cause an index out of bounds error. The first protective measure is going to check to make sure that our middle index is within the bounds of our array. So it's going to have a value that is less than we want to say that if it has a value greater than or equal to our source array, then we're just simply going to stop and do nothing. If this should occur, if the middle index gets a value greater than the end of our array, then our method is done and we don't need to do anything else. The other condition we're going to check for is to make sure that our right end value, if it should have a value greater than our source array dot length, in that case we're going to simply set it equal to our source array dot length. And the reason for this particular check is that if you have an even power of 2 number of elements in your array, your list will always end nice and evenly with right end being the last element. But if you have any other number, you're going to have leftover elements. And this little check makes sure that you never go beyond the number of elements you actually have. Okay, so what happens next? Well, for our next check, what we're going to do is go back to our list and see what our next step is. Our step 2 is to merge the elements of the temporary array back into the source array until one of the subsections runs out of elements to be merged. So, let's think about this process. Before we had 2 separate lists. We still have 2 separate lists, but our list is actually made up of elements within one list. So our first list has the elements 0 at indexes 0, 1, and 2, and our second list has the elements at indexes 3, 4, and 5 in this example. So when our algorithm does our comparisons, instead of comparing indexes from 2 different lists, we're comparing the element at index 0 with the element at index 3, which is the first element of the second portion of this list. So, other than that, the algorithm continues just like it did before, taking each next lower value, copying it back into the array. The process looks like this with this sample list. If list 1 is 2, 3, and 5, and list 2 is 1, 4, and 6, then first 2 and 1 get compared, and 1 gets put in the very first position. Then 2 gets put into the second position, 3 goes third, and so on down the list. So let's look at how we do that in Java code. So, put some blank lines here. Okay. So, now we're going to start with our while loop. Just like before, before we begin, we need to set up some index variables. So, we need our left index, which is going to represent the current position in our left or list 1. So, it's going to have the value of left start to begin with. And then we need our right index. And it gets middle index as its initial value, because remember, middle index represents both the end of our left list and the start of our right list. Okay, and then we also need to know what our current copy position is within our original list. And that always starts out with our left start value. Because our array elements are going to get copied back into the source array, starting from the same place where we started with our left half of our list. Okay, now we can write our while loop. So, we're going to say that as long as our left index is lower than our middle index, then we want to keep going. And if our right index is less than our end point, the end of our right list, then we also want to keep going. Now what we have to do is compare the values at the 2 positions in our list. So we're going to write our conditional statement. What goes inside the parentheses? Well, first, we're going to look at temp array at the left index position, and we're going to see if it has a value lower than our temp array at the right index position. And then it's either going to be less than or greater than. If it is less than, then that's the value that we want to copy back to our source array. And where do we want to copy it to? Our current copy index. What value does it get? Well, it gets temp array left index. And because we've used left index, we need to increment it so the next position in the list will be checked on the next pass of the loop. And the same thing goes for the right half if the right half of the list contains the lower value. But instead of left index, it's right index. And in that case, we need to increment our right index counter. And in either case, we've added an element using current copy index, so that needs to be incremented. Now, remember that in this example, it will go through each portion of the list until one of the lists runs out of values. In this example, that leaves one value, the final value, yet to be copied. So that is represented by step 3. Copy all the remaining elements in the temporary array that did not run out of elements back into the source array. So that's what we're going to do next. And just like before, that's going to be a while loop. Now, since we don't know which list is emptied, we first check to see if left index is still lower than middle index. And if it is, then we copy to the source array at the current copy index the temp array value pointed to by left index. And then because we've used left index, we increment it. And in this case, we've used our current copy index. So we increment it as well. And if it happens that our right list is the one that still has values in it, then it will have a value lower than our right endpoint. So we'll copy from the source array the current copy index from our temp array at right index. And because we've used right index, we increment it, and we also increment our current copy index because we've used it. Okay, now all that remains is to return our list, which happens without us having to do anything. So this completes our merge method. But notice that our program doesn't call our merge method. It calls MergeSort. And this is where we have to actually put our code that calls our merge method. We can say that the merge method takes care of the divide portion of our list, or rather, I guess you could say it takes care of the conquer. What we have to do now is actually divide the list. So let's look at how we do that. Down here is a diagram that shows this process with the example data that we have in our program. What's going to happen is, remember, our merge method only merges lists that are already sorted in order. But if a list only has one element in it, by definition, it has to be sorted in order. So if we start by looking at lists that have one element and merging those two lists together, we can say that we can safely merge them. So first, we're going to merge the first two elements in our list, giving us a list of two elements back that are sorted. Then we're going to merge the next two elements, putting those in sorted order. And then the next two elements, putting them in sorted order, and so on. If our list has 16 elements, we have to do this 8 times. Now our list has pairs sorted in order. So what we could do is merge this pair of two elements with the pair of two elements next to it in the list, giving us a list of 4 elements all sorted in order. Repeat that process for the next 4 elements, and we get them in order. On the next pass, we'll have a list with 8 elements in it after we merge 4 elements, and 4 elements, giving us a total of 8 elements all in order. We're almost there. For our last pass, we merge the left 8 elements with the right 8 elements, giving us a total sorted list of 16 elements. Notice that in each pass, the size of the number of elements that we're merging doubles. First it's 1, then we're merging 2, then we're merging 4, then we're merging 8, giving us a list of 16 totally sorted elements. So let's see how we write that in Java. Okay, so what we're going to do first is take this progression here. And what we're going to do is write a loop. And we're going to say, how many elements are we going to have in a block that we're merging? We start with 1 element. So we're going to say we have a block size equal to 1. Then we're going to have this block size increase until it's, as long as it's less than the size of our array. And finally, what's going to happen to block size each time? Well, the first time our block size is 1. Then our block size becomes 2. Then our block size becomes 4. Remember, a block is how many elements are in each half of the merge that we're performing. And then 8, and then we're done. So, what happens to block size each time? Well, it gets its old value times 2. Each time it gets doubled. And a shorter way to write that is to say that it is times equal 2. Okay, now what we have to do is actually call our merge method using this block size to repeatedly merge our small lists. So what we're going to do is write a loop that says our left side, or our left start, is going to be equal to 0 when we start, and each time, you know what, we'll call it our left index, just so it's the same name that we used in the document. So our left index is going to start with 0, and it's going to keep going as long as it's less than or equal to the array length. And then each time, our left index is going to increase in value by the block size times 2. So why did we choose these values? Well, our left index for our first merge is 0. When our block size is 1, what's the index for the next start of our next block? This is index 0, 1, and 2. If our block size is 1, we need to go from 1 to 2. So our block size is 1, we double that, we add it to our current block size, and we get to 2. On the next pass, our block size is doubled. So our left index jumps from here all the way to here. Each time, it goes up by double the current block size. Now we're set to actually call our merge method. And this is where our values need to be calculated. I've made a chart to try to illustrate how this is going to work. So, when block size is 1, our initial left index is going to be 0, then 2, then 4, then 6, then 8, 10, 12, and 14. Each time it's increasing by 2. And when we call our merge array, our merge method, the first thing we need to pass it is our array. The next thing that we need to pass it is the start of our left side of our list. And we want to merge starting with 0, so we're going to give it our left index. Then for our second value, which is our middle index, well, in this case, it's going to be the left index plus the block size, because each time it starts at left index and goes for as many elements are in the block that we're merging. So it's our left index plus block size. And then finally, what is our right value? Well, it's going to be the end of what we're trying to merge. So it's going to have the left index value plus 2 times the block size. And now we will be calling the merge method in this pattern that you see here. When block size is 1, it will get 0, 1, and 2, then 2, 3, and 4, 4, 5, and 6, and so on. When the block size doubles, the number of elements doubles, so it starts with 0, goes to 2, and then ends at 4. Okay, we've now written all of the code necessary to actually see this process in action. Our next step is going to be to try to follow the code to see what it does. So we're going to watch each time the merge method gets called. And to see it function and see what the array looks like each time, we're going to put a stop right on this portion of the for loop so that we can see what the array looks like each time a merge is about to be performed. And then we're going to run it in debug mode. Now, at this point, I can click on ARR to see the current values in the array as it stands. So, if you look at your sheet of paper, hopefully you have a printout, I would suggest that you should go back to this diagram, because this is what we're going to see happening. Our merge is going to follow this pattern. First, it's going to compare 3 and 2 and swap the values 2 and 3. So I'm going to hit the resume button, and as you can see, 2 and 3 just got swapped. Remember, our block size is 1, and our left index is currently 0, but now we're going to go through the next iteration of this for loop, so left index is about to become 2. And it didn't need to swap 1 and 4, that's these two elements, so you didn't actually see anything happen. But the values did get copied back into the array. 13 and 10, our next two elements, will need to get swapped. Then 12 and 15, that's going to be these two, but they stay the same. 9 and 6 do need to be swapped, so we're going to see those two switch. And then 11 and 7 will also switch. 5 and 14 will stay, and 8 and 16 will stay. Now, on the next iteration, our block size should go up. And now we are going to see our 2, 3, 1, and 4 get merged together. So, our block size is now up to 2, and when we run this, we'll see these 4 values get put into numerical order. Within our page, we're at this point of the program right here. We're about to merge these 4 values, giving us this result. So, let's resume, and we get 1, 2, 3, and 4. On our next pass, 10, 13, 12, and 15 should get sorted into order. Then 6, 9, 7, 11. And then 5, 14, 8, and 16. And then our block size should increase on the next pass. And now our block size is 4. So we are now at this step of the process. We're now going to merge these four with these four, giving us a list of the first 8 elements all sorted in order, and the second sorted in order. Okay, then our block size is going to increase to 8. And this should be the final pass required to get our list completely sorted. And there we have it. Our list is completely sorted. I'm going to switch back to the Java view and run the program. And you can see the results right here. Before, this is what our list looked like. After, this is what our list looks like. This is a complete merge sort algorithm. Now it is time for us to gather the metrics or efficiency of our merge sort method so that we can fill out the worksheet. This process is somewhat more complex in this case because of the way this code is written. So what we're going to do is first go to the website and copy these 4 lines of code. These are some constant variables that we'll be able to use in our method to make this process easier, and then paste them in above the main method. Now, these constants consist of a string array that identifies what things we're going to be gathering, what information. In this case, the length of the array, the number of compares performed, and the swaps. And these labels are stored in a string array. Next, we have a constant variable that defines what label is stored in each position. So the array size is in element 0, compares is in element 1, and swaps is in element 2. Then, in our merge method, we're going to, or our merge sort method, we're going to change the return type from void to int array. And because it now has a return type, we're going to want to create a new integer array, which we'll call results, and we'll set it equal to a new int array. How many elements will be in this array? Well, we could just set it to 3, but if we want to make our program flexible for the future, say we wanted to add another metric later, if we make it equal to our merge sort class dot results, result labels dot length, it will be set to 3 now, but if I were to go in and add a 4th metric, it would still automatically get included. The array size would change, and therefore there'd be room for the new item. Okay, this is referred to as robust code design. Next, we're going to fill our integer array with our initial values. So, our int, our results of merge sort dot length, rather array size, is going to be equal to r dot length, and our results for our merge sort, our compares so far are 0, and finally our swaps are also 0. And then when we're done, we're going to return our results. Okay, the only problem is so far our compares and swaps are 0, and that's not terribly helpful because we of course know there will be some array swaps and compares performed. But where do they get performed? It turns out, of course, that they get performed in merge. Therefore, what we're going to need to do is to take this array and pass it into, or rather gather the results from the merge method, which means that the merge method now is also going to have to return an integer array. So once again, we're going to have a new int array, and we can just copy these lines here because we're doing the same thing. And the only difference is the length is actually the source array length. Okay, now when we return, we have to return the results here, and at the end of our method, we also have to return the results. Now all we have to do is actually fill the results in with some values. So, what values do we want to use? Well, first we need to figure out where we've done a compare. So right here, we have performed a compare. So we would say results compares plus plus. And at the same time, here we've done at least one swap. So we'll also increment our swaps. Then down below here, inside each of these while loops, we're performing a swap, but we're not performing a compare. Now when we return the results, they should have some valid numbers. The only problem is the way that we've written this, results is getting overwritten each time the merge method gets called, and what we want to do is have a running tally. So what we're going to do is the array size will never change, so we can leave that one alone, but we're going to need an integer called swaps and an integer called compares that we'll use for this outer method, and each time we get results back, we'll take our compares variable and we'll add to it results of our merge sort dot compares index. And then we'll do the same thing for our swaps so that that gets a running tally. And then once the loop here has completed, we'll copy those values. We're going to just reverse this process and say results of the merge sort for compares gets our compares value, and the results for our swaps will get our swaps variable. Now, when the method returns, we should be able to see how many swaps and compares and how long the array was. So let's see how that would work. First of all, let's check and make sure our program still works and that there are no errors. Whoops, didn't mean to run it in debug mode. Let's run it in normal. Try that again. Okay. Alright, so the program is still working. We haven't created any horrible errors. So now we can go back to our main method. Notice that we're calling MergeSort, but we're ignoring the result right now. What we're going to want to do is have our int results array equal our MergeSort, and then afterwards now we can output the results. And this is where this little structure that we set up here can save us some time, because we can write a loop that will loop through each of the values in our string array, our result labels dot length, and for each of these we'll output our merge sort dot result labels of I plus an equal sign plus our results of I. And if we've done this correctly, the first label will be length, and the first number that will get stored and returned in results should be the number of elements in our array. The second will be compares, and the third will be swaps. And here we go. We have a length of 16, 45 compares, and 64 swaps performed. Now we can change our integer array so that we can return only the elements that we want for a length that we want. So instead of giving our array this arbitrary length, we will set up a new int array, and let's create a new public static final int num elements equals 5. That will be how many elements we're going to put in our array. Equals keyword new int array. And then now we need to fill our array with values. Now, we had written some code to do this before, but since that code is not here, it will be good practice for you to go through and write that code. So, for int I equals 0, I is less than r dot length, I plus plus. We're going to iterate over the whole loop, and we're going to give r of I a value equal to. Let's start by doing an array sorted by length, sorted in ascending order. So this would be data that's already in the proper order. 1, 2, 3, 4, 5 is our result, and 1, 2, 3, 4, 5 was exactly how our data started. Nevertheless, it had to perform 8 compares and 13 swaps in order to get our list unchanged, essentially. So, what happens if we change num elements to 10? We've doubled the size of our array. What happened to our swaps? Well, it went from, let's run this again. With 10 elements, it was 36. With 5 elements, it was 13. So, it more than doubled. What happens if we go to 15? Look at our number of swaps. It's going up rapidly. But let's go back and look at our number of compares. So with a 5-element array, we get 8 compares. With a 10-element array, it only went up by 11. And then when we go to a 15-element array, it went up to 31. Notice that the number of compares actually went up by a lower value this time. So, now you have everything you need to fill out the chart. All you have to do is change the data that goes into the array to the best, worst, and random cases, and change the number of elements and write down your results.